Hey guys, how's it going? This is Ryan from O2BT. Today we're going to go over the technical interview question, write a function that generates the nth number of the Fibonacci sequence. For this tutorial, basic knowledge of recursion would be helpful, but it's not needed, and you should know about functions in C++ as well. Alright, let's get to it. So here we have the outline of a program. We have a main function here that takes user input in, and it asks what is the number in the Fibonacci sequence that you want, and the user will input a number, and it'll output the corresponding Fibonacci number. And for those of you who don't know, the Fibonacci sequence looks like this: 1, 1, 2, 3, 5, 8, 13, dot, dot, dot. And you'll notice a pattern here where it starts with 1, 1, actually technically 0 it starts with. So it'll go 0, 1, and then after that, every number is the sum of the two numbers before it. So 1 equals 1 plus 0, 2 equals 1 plus 1, 3 equals 2 plus 1, and so forth. And so that's our Fibonacci sequence. There are two approaches to this problem, and one is significantly better than the other. So I'm going to go over the good way and the bad way, and we'll actually start with the bad way, which is a recursive function. And so Fibonacci sequence is a canonical example of recursion because we have this identity that Fibonacci of the nth number is equal to Fibonacci of the nth minus 1 number plus Fibonacci of n minus 2. And so we can use this identity to easily program a recursive function. And so like in all recursive functions, we'll first start with our base case. And our base case is the first two terms in the series. So we have 0 and 1. So we'll say if n is equal to 0 or n is equal to 1, we'll just return n. Otherwise, we have our recursive case. And that is Fibonacci. We're going to want to return Fibonacci of n minus 1 plus Fibonacci of n minus 2. And that's actually all there is to it, because this identity here gives us everything we need. If we wanted to find the fifth Fibonacci number, for instance, which is 3, then all we need to know is how to compute Fibonacci, the fourth Fibonacci number and the third Fibonacci number. And to compute the fourth Fibonacci number, we need to know how to compute the third and the second, and so on. You sort of see this recursive structure here that emerges. But there's an issue with this. It's really, really slow because we're using so many recursive calls, and that is not ideal. So I'm going to try and compile here, and we'll see how slow that this is. So we have a warning. Oh, that's fine. /a.out. So what number in the Fibonacci sequence do you want? We'll say 0, and it'll say 0. And this is 0 indexing. How about 1? It'll give us 1. How about the second one? Also 1. Good. Okay. So let's try and get like the fifth number. It should be 5. And so there we have it. All right, good. But what if we said the 100th number? We're going to be here, and it'll wait for a long time before returning a number. So we definitely do not want to use recursion for this. Even we could try the 50th number, and it's still not going to get it right away. The reason is there's so many recursive calls that the stack just gets overloaded, and it has a lot of work to do for one function call. So you can see here it's not even done computing the 50th number. I think earlier when I was testing this, it could reasonably compute the 40th one. Yeah, see, there's the 40th one. But beyond that, it really takes a long time. So the idea is that we want to trade space for time, because space is much more plentiful these days than time. No one wants to be waiting around, but we do have the space for solving problems. And so what we're going to do is we're going to make a table, and we'll call this fib table, and it'll be size n plus 1. And we'll say that the first two entries in the fib table are 0 and 1, because those are the first two numbers in the Fibonacci sequence. And now all we're going to do is we're going to rely on the values in the table to give us what we need. So we'll say for in I equal to 2, I less than n, I plus plus. So we're going to iterate up until the nth Fibonacci number. And we're going to fill out this table. We're going to say, fib table of I equals fib table of I minus 1 plus fib table of I minus 2. And the idea here, again, is that we're storing the values of the Fibonacci sequence, so that way we're not recomputing them. And so that is in line with this idea of trading space for time. Space is much more plentiful. And you'll notice that this is actually a lot faster than what we have previously done. And so we're going to want to return fib table of n, and after that, I think we're good to go. I'm just going to change this up here, Fibonacci 2. All right, so let's compile. All right, actually, just so there's one thing here. We want this to go up until n plus 1 because we just want to fill out the whole table. So we'll just make sure that that's there. All right, now we can compile. So we'll do g++. Great, everything works. What number in the Fibonacci sequence do you want? Let's just start with some basic ones. So let's say like 5, for instance, and 5 was the return value that we got earlier. What number do we want? Let's try 40. We'll see how fast this is compared to the other method. Yeah, great, super fast. What about 50? It couldn't compute 50 earlier, but here it does it well under a second. All right, so we can try maybe up to 70. At some point, there's going to be an overflow because our data types in C++ are only so big. They can only store numbers up to a certain value. You can see here clearly that trading space for time definitely improved the runtime of our algorithm. Speaking of runtime, this old recursive solution here is exponential runtime because of the recursive calls. There's a lot of recomputation that's done, and so we want to avoid that. That's a huge negative aspect of recursion, is that sometimes you end up doing a lot of recomputation. This dynamic programming method here that we did, this is in O of n time because, as you can see in this code, we're really only iterating through a table and filling out n entries in it. So thanks for watching this video. I hope you guys see the trade-off between space and time, and I hope it's clear now that dynamic programming can be used as a useful tool. So I hope you use it in any technical interviews you might have. Thanks for watching again, and don't forget to subscribe.